Hello, hello, hello. Cheers, Kevin here, and welcome back to TIS-100, where, we've unlocked these new things. We're going to start playing around with this. Oh, we fixed the simple sandbox? Did we? Oh, no, it's just already nominal. We've unlocked these. We've completed these top 5 segments, and now it's time for us to start looking at these new ones, which I imagine are going to be much trickier. So we've got a sequence generator. Now here's let's see. Sequences are 0 terminated. We need to read values from in A and in B. We need to write the lesser value to out, and then write the greater value to out. Okay, and then write 0 to end the sequence. Okay, this is going to be tricky. So we need to write these in the correct order. Yeah, okay. So we need to, okay. So they're all, okay. Cool. So here's an example. We get 4671, they go 4671, 0. 2971, 0. 6690, 0. Okay. So what I'm going to do is I'm going to move up to, shoot. So here's the thing, is that the only sort of branching logic, in other languages you might have something like if. You'd be like, if A is less than B, then we could go to something else, or do something. The only jumping logic that we have is we can say jump, which just jumps. We can say jump if equal to 0. And that's based on the accumulator value. We can say JGZ for jump if it is greater than 0 and jump if it is less than 0. So we're going to have to do some subtraction, and we're going to have to do that without removing stuff. Okay, let's try this. I'm just going to move up to the right. So in A is just going to jump. Oh wait, we've got the debug stuff. The new girlfriend has encouraged me to get rid of the microcomputers I've accumulated over the years. Not a bad idea. Most of them are just taking up space and aren't doing me or her any good. Going to wait on this one, though. Never found what its whole deal is, and if it turns out to be something I wasn't supposed to have, and I think I could get in trouble. Glued a little space on the workbench and hooked it up. Still works. Beautiful. 44.R0. Yes, it is a beauty, this one. All right, cool. All right, I'm going to go ahead and just move up into the accumulator. So I'm going to put B into our accumulator value, and then I guess we'll have to save. And then, let me see, can I subtract left from the accumulator? And then we can do some jumping logic, maybe? Let's try that. So we did get up, we put it in the accumulator, we subtract the 46, right? Or, well, we save and then we subtract the 46, we get 25. We see that, wait, we're just trying to figure out which number is greater, right? Yeah, so yeah, then we can jump. And we've got this saved. The problem is we don't have the A value saved. So we're going to have to... Actually, okay, so this will fine. This will say, I'm going to give you the number twice. Once so you can subtract it, and later so you can decide to use it. Okay, so we subtracted the left. And if, let's assume... Let's see. We'll say we'll jump if it is greater than 0 to some label. Well, let's say label. Oh no, we just say label. Let's put a line here, an empty line, just for the sake of this. So we'll say if it's, let's see, by default we'll just, okay, let's say B first is going to be our label, and I'm just going to say move. Okay, there's B first. B first. Let's see, we're going to have to swap. And then move down, move accumulator to down, right? So if B is the correct one, then it's already been saved into our backup. So go ahead and swap our backup in the accumulator and then move the accumulator down. And this is just going to be move up to down, and this is just going to be move up to down. Let's see. And well, okay, we're gonna have a little bit of duplication here. We'll make it work first, and then we'll make it good second. And after we move B to down, then we'll move A to down. So move right down, and we'll say A first is end. Then we'll have to go jump. Let's see. We'll say begin. Yeah. So jump to begin. If A first, then move right to down, and then swap, and then whoops, swap, and then. Move accumulator down. And then we don't need to jump. Yeah. So there we go. Now we need to figure out if we need to jump to A first. So we've subtracted, so we had B, we said B minus A, if it is, let's see, we need to get the smaller value, right? Darn, my brain is spacing out on this. Jump if it's either less than 0 or greater than 0, and I don't remember which one. Okay, A minus B. So A, let's look at these examples. So B minus A, that means that we need to write the lesser value first. If we subtracted A from B, we'd end up with a positive value, and so we should write A first. So if greater than 0 to A first. There. Let's try this. Now, of course, we're not actually writing any zeros, though. We're going to have to worry about that. Okay, so found A first, so it's going to move the 71 down. Oh, shoot. We shouldn't say right. It should be left. And both of these are broken, actually. Left. Yeah, we're not moving these things from the right. Left. There we go. Okay. We're not doing the zero termination stuff just yet. So A first, we're going to move that down. Good. We move that down. 71. No, we did it wrong. No, we did it wrong. What did we do? What did I do wrong? Okay. Jump if less than 0 to A first, otherwise B first. Wait a second. No, A first should mean that we move left to down. Wait a second. Why was A 76? What? I'm confused. Step. It gets 46. Oh, no. Yeah, no. We can't just move up to the right. We have to save it. So we're going to move up to the accumulator, and then we'll move the accumulator to the right. Because otherwise we're taking this second value, this 71. Not B's 71, but A's 71. Okay, so now we do this. And we go to B. Wait, no. I fixed that wrong. We should. So jump if greater than 0 to A first. So now we got this. 46, and we should have 71 coming in. Yes. And now this is going to start from the beginning, and we should get what? 29 and then 71? 29, 71. Right, now it's mad because we didn't zero terminate stuff. That is okay, though. We can just say move up to down, and then move 0 to down. Right? Because these are always going to be sequences of 2, so we're fine. Let's step through this and just see if this works. 46, 71, 0. 29, 71, 0. Good. All right, let's run this. Ba-doom. Test 1 passed. Test 2 passed. Test 3 passed. And a random test. All right, good. We did it. And it looks like we didn't do too bad. A lot of people used more nodes, and a lot of people managed to do it. Some people managed to do it in fewer instructions. But yeah, let's see if we can edit this a little bit more. So if we again move up to accumulator, subtract first. This may not be the worst. I feel like there's some shared stuff here. The whole moving down thing. Let's see. Yeah, the problem is we can't move left down. I'd like to avoid this whole this stuff is repeated. So the move accumulator down. Actually, hang on. In either case, swapping is not going to be a problem here. So we don't need both swaps, right? Swapping is not going to break the functionality. So we'll say swap and just get rid of it here. And I think this counts as an instruction set. So we'll say move left down. Oh, no, I can't do that. All right, we'll just say A. We'll call that label A. Move left to down. And I'm going to remove the empty spaces because I don't know if those count as separate things. So this will be move accumulator down, move left down, jump again, swap, and we'll remove these empty lines. And we've got to get rid of A first. A. Wait a second, we're never jumping to B, so we don't need that label. So we've just got this. Okay, so now we have this thing that should be fewer lines, maybe. Yes, we've got fewer lines, I hope. Oh no, we broke it. What did we do? All right, let's look at what we're doing. We save, we subtract left, we jump, we say, all right, move left. Oh, no. We put that in the wrong place. The swap needs to go before the jump, Kevin. Swap. Oh, no, we can't. No, we can't swap before the jump because we're using that as the value to test things. So, okay, swap. And we do need the swap here. Well, that's a shame. All right. There we go. But we're still, okay, that didn't seem to affect anything. We're still dealing with what we're dealing with. That's not the worst thing. We'll return to the segment. Listen, call that good. 132 cycles and could be better. All right, so that's us. Let's look at the sequence counter. What is the sequence counter? Let's create a new program and see if we can fix this. Sequences are zero terminated, as before. Read a sequence from in. Write the sum to out S. Write the length to out L. Aha. Okay. Okay, this is cool. Oh, we got a communications failure. No, she won't understand. Of course she doesn't. Why would you expect her to? Just keep working. I feel like I'm learning something about the people behind this and their design decisions, the thoughts that went into figuring out how things should work. For those people feel very close to me now. Lee. Okay. So we need to, now we've got zero terminated stuff here, and we're not outputting a sequence. We are counting and adding the sequence. So cool. Let's see. So let's say this one's job is just to decide if we're done. Right? Right? Maybe? No. Okay. Well, let's see. Let's just move up to the accumulator, and we'll move it out into two directions. We're gonna move accumulator to down, and we're gonna move accumulator to the right. And this one's job is just gonna be to so we'll just say move left to the add left and swap. Nope. Let's see. Yeah, okay, we'll say add left, and then we'll say jump if equal to 0 to done, and we'll say done. Oh, wait, jump if equal to 0 to done, and done is our label. Let's just move up to down, or move accumulator to down. This is going to be totally wrong. That's okay. Let's worry about the length thing first, right? Okay, so we'll ignore the moving down thing. We're just going to move up to the accumulator because I think we're going to need two separate nodes to worry about this math. So okay, this one's going to go. It's going to add left, and then it's going to go to done. It's going to move the thing down, right? So we need to change the logic though. So basically, we need to go. Can I do comments like this? No comments. Yeah, comments. So if the value is down, if accumulator is equals 0, then what do we need to do? Well, we need to get the value from. Yeah. Then we're gonna. Okay. So if it's not 0, not equals 0, then what we want to do is what we want to do. What do we want to do? No, shoot, we can't use that as the 0 thing, can we? No, I think we're going to use more nodes. We're going to have something just be the counter, right? No, we can't have it be the counter either. Okay. Okay, I'm going to do something really dumb. We're just going to scope this out, try and get this thing to work. We're going to move left to null. So move it to nothing. Wait, to nil? Yeah, move it to nothing. And we're going to say add 1. No. Yeah, no. Yeah, because we're doing a count. We're not doing a sum. So, okay, shoot. Okay. Yeah. Okay. So we'll move the left to the accumulator. Then we will say if it's equal to 0, then we'll get it out. So we need to go if e equals 0, get it out. Get our backup value out. Dump the backup value. Else, backup value needs to be incremented by 1. We need to add 1 to the backup value. So that's okay. We can do that. Adding 1 to the backup value. How's that going to work? Well, we would have to swap out what's in the accumulator. So we need to get the value out of the backup and then add 1 and then put it back in. Swap. Let's see. Do we have a jump not equal to 0? JNZ. So jump if not equal to 0. Yeah, I think this will work. So jump if not equal to 0 to No. Yes. Jump if not equal to 0 to done. Done. And we'll say this is done. So done is the swap and add 1 and swap. If it is 0, though, then we need to get the backup value. So we'll need to swap, and then we'll need to move. Let's see. Move accumulator down. And yeah, then we'll need to swap again because this other swap is going to be a problem. I think that should work. That should add 1 unless it gets a 0. So let's see. Getting a value, we get a 35. So we jump, it's not equal to 0. So we swap and we add 1 and we swap. And now it's waiting for the next value. It sees a 0 and it doesn't find it. So it goes ahead and pushes it down. Good. Okay. Let's see if those values work. We'll just move up to down and we'll move up to down. And let's run that. No, 7. No, that's not working. All right, shame. Well, okay, let's step through and see why that wasn't working. So, okay, we get 31, that's done, and then it goes, hey, I got a 0, so I'm done. Right, so it's going to move its 1 down. That's correct. Now it gets a 60. Well, no, hang on. Now it's in done. Wait. Let's see. Yeah, no. Hang on. Swap, move the accumulator down. No. We want to change this. So jump if equal to 0 to done. Yeah, these are backwards. So swap and then move the accumulator down. And then swap. And here, we'll say add 1. But we need to jump back to the beginning. So begin, move left down. Jump to the beginning. Whoops, what did I do? Jump to the beginning. Okay, so we've got this. We go, hey, is the sequence done? No. So we're just going to do our normal stuff, which is going to be to add 1. And then we go to the beginning. Then we go, hey, the sequence is done. So we go to the done thing. We move the accumulator down. And we swap. Why do we swap? No, we don't want to swap. No. Well, actually, we could swap. I mean, we could move 0 to the accumulator, but since it's a 0 anyway, it doesn't really matter. Okay, so then we go, okay, we say, hey, are we done? Oh, no. That's the problem, is we are saving a bad sequence now, right? We're evaluating 60, well, we'll see. 3, 4, 5, and now is what's it going to get? As it gets a 0, but it's already adding 1. Yeah, that's not right. All right, if we are done, we move the accumulator down. We need to make sure that there is a 0 in the backup. So we'll say move 0 to the accumulator and then swap. And there we go. That should ensure that we start off with the right values. So 1, 0, 1, 2, 3, 4, 5. And it gets a 0, so it's done. So it moves that thing down. And there we go. Now, yeah, okay. Now we're counting things correctly. Hooray for us. That's good news. Now we should be able to hopefully do the same thing here. We're just going to, instead of adding 1, we'll need to add the correct value, right? So we'll do begin, move up, down, up to the accumulator. Say jump if it's equal to 0, then we're going to go to done. Done is going to be the same, right? It's just going to be swap, and move accumulator down and move 0 to the accumulator and swap. So here we're, instead of adding 1, we're adding, move up to the accumulator. There we go. Let's see. Now this is going to be a little tricky though. Instead of adding 1, we need to add the value. Can we add backup? Probably not. No, it looks like we can't. So we're going to need to store away the number, even though we're using the number to check. All right, so jump if equal to 0. Otherwise, get our sum out. And, whoops, swap. So we've stored the sum, presuming we've stored the sum over here. Now we need to add it. We need to add the next value. Unfortunately, our value is in the backup, which is annoying. So we're going to have to, I think basically what we're going to do is we're going to need to move this around. twice. So we're going to move accumulator to the left as well, and then we'll just move up to down, and then we'll just move, we'll move right to down, and we'll move up to the right. So it'll come in this way too. So instead of adding 1, we will add the value from the left. If we're now that does mean we're going to need to clear out the zeros that end up getting in here. Well, no, actually, we can have this buddy worry about filtering out the zeros. So he's only going to give us the numbers if we already know that we're going to need them. So we'll add the left, and then we'll swap, and then we'll jump to the begin. Whoops, there we go. Jump to the begin. Okay. Now, we're going to go move up to the accumulator. Actually, let's go ahead and push this stuff to the left first, because that's going to take longer, I think. We'll move up to the accumulator, and then we'll say jump if it's equal to 0. So we'll say begin. Jump if equal to 0 to begin. Otherwise, so if the value we just got was a 0, then just get another one. Otherwise, move accumulator to the right. Okay? So now we've got a lot of things happening. Let's see here. We've got the left. Okay, so this is it's got its 35. This thing is waiting for its value. We get the length one is fine. We're not moving it down. Whoops. All right, move the accumulator down as well. Yeah, this is getting messy. All right, so we take the thing, we move it to the left, we move it to the right. You guys worry about that. And it's fine. It says that's not a 0, so I'm going to go ahead and give it to this guy who's going to calculate the sum. And now it's going to move it down. Now we're going to say, all right, we move that into the accumulator. It's not a 0, so we're going to swap out our backup, and now we're going to take the 35, even though we just had the 35. We're going to take it there. And actually, we could do this without... well, we could do this with... We could just have move the accumulator down twice, right? I think. Well, no, because then we'd have to worry about filtering out the zeros anyway. So, okay, we swap that, and we go to the beginning. So we've now got 35 in the backup, and the next value that we get should be a 0. And so we say, hey, we're done. So we take it out, we move it down. Oh, we don't have anything here. All right, move up to down. Okay, let's go through this again. We get our 35 saved. Now we have a 0, so we go, we're done. We take the accumulator value, we move it down. We put a 0 in the accumulator and store it out. And I feel like the move 0 accumulator is not necessary, but we'll see. All right, the next one is the important one. 62. Okay, so we actually got to get a sum here. We got to get 260. So we get 62 in there. Now we swap these, and we get another thing. We get 113. So we are summing these things. It's just a question of whether we get out at the right time. 248, 260, and now we should get a 0. It means we jump to done, and there we go. Yes, cool. We got the correct value. Okay, I think these move 0 to the accumulator things are not a problem because we have already asserted that. Oh no, we have swapped. Yeah, but no, we swapped because the move 0 to the accumulator is not necessary. We'll strip these out. Let's go ahead and run this quick and just see. Oh no. Okay, let me put those back in real quick. Move 0 to the accumulator. Yeah, we got a bad length too. Move 0 to the accumulator. Let's run. Yeah, okay, so we do need it, and I'm not 100% sure why. But okay, let's go ahead and run this, and we are good. Now, we are using more nodes than some people have. We're using, well, we're on the low end of cycle count, though. That's pretty good. We have more instructions than most people. I suspect that what most people probably did is they just ended up, move accumulator down twice, and then... Yeah, we can, instead of getting it from the left, we could say, hey, if it's a 0, then discard it. Otherwise, use it. But, this way we don't have to worry about it. This box's job is just filter out the zeros. And this box is calculating. Oh, man, we are getting crazy with all of this stuff. Well, let's go ahead and, we've got this one done, so we'll go ahead and jump out. We'll look at the segment list. Look at that. We've already unlocked a whole bunch more stuff already, some of which is nominal. So that's pretty exciting. And yeah, we're at like 25 minutes. So I guess we're going to have to end things there. We'll sneak peek at what the signal edge detector is going to be for next week. So read a value from in, compare the value to the previous value, write 1 if it changed by 10 or more. If not true, write 0. And the first output is always 0. All right. So it's an edge detection. It's determining when we go from just when things change drastically. We just need to output a signal that, hey, something is different. I feel like this should be really easy, though I'm, open to being surprised. Anyway, I will hope to see you next week with some more awesome TIS-100, and I will see you then. Cheers.